In a recent experiment, the test area was flooded with debris from destroyed targets. This marks a breakthrough in weapon technology, the latest laser gun from the United States. Unlike previous laser weapons, this new gun operates on a completely different principle, offering extremely fast speeds and absolute precision. Its power is thousands of times stronger than any known laser, heralding a new era in modern warfare. But can you imagine the power of a laser gun? This isn't just an offensive weapon, it's also a defensive shield for allies. So, why have countries been racing to develop laser weapons since the 1960s? Simply put, lasers have distinct advantages over traditional weapons. Specifically, laser beams travel at the speed of light, leaving no time for the enemy to dodge. In aerial combat, this is a matter of life and death. There's no recoil, no ammunition. Laser weapons are only limited by the energy supply. Imagine a powerful, sharp beam that can pierce any barrier in the blink of an eye. That's the power of the most advanced laser system that the United States has just perfected. In today's video, the Navy Power Channel will take you on a journey to explore this groundbreaking military technology with the potential to change the course of modern warfare. Don't miss the opportunity to learn about this incredible advancement where the future of war will be shaped by light. Before this super powerful laser gun arrived, the US had already deployed several combat laser systems, each with unique features and capabilities. For example, the Boeing YL-1 laser system, developed on a Boeing 747-400F aircraft platform, was capable of destroying cruise missiles and ballistic missiles, including those carrying nuclear warheads. The Boeing YL-1 not only contributed to the development of next-generation laser technology, but also played a key role in the Sky Dominator (NGAD) program, an initiative to develop sixth-generation fighter jets equipped with powerful laser systems. The Boeing YL-1 uses an extremely powerful laser beam emitted from a highly accurate optical system, capable of destroying targets within seconds after determining their coordinates. Importantly, this system can intercept missiles in mid-flight before they reach their target, helping minimize damage and optimize defensive strategy. With an effective range of hundreds of miles, the YL-1 can destroy a missile in just a few seconds without expensive ammunition. This not only reduces the cost of military campaigns, but also transforms global missile defense strategies. And that's not all. These laser guns can destroy airborne targets and even disable enemy nuclear power plants from afar. In McKinney, Texas, it only took 9 months to produce a laser weapon system for the US military at the first factory dedicated to laser weapon manufacturing. The US military's mobile laser systems, such as the M-SHORAD system installed on the Stryker A-188 armored vehicle, can destroy airborne targets with a 50-kilowatt laser, capable of taking out artillery shells. This system has the potential to change the battlefield, especially when facing large-scale artillery attacks. The M-SHORAD's active radar and guidance systems enhance targeting accuracy when attacking missiles, aircraft, and ballistic clouds. Additionally, the US military has developed smaller laser combat systems to handle small, easily overlooked targets, such as drones. One of these systems is a pickup truck equipped with a 10-kilowatt laser, capable of destroying drones on the battlefield while constantly moving and occupying covert positions. Such systems play a crucial role in protecting attack units and supporting defensive strategies. In the world of modern warfare, the integration of laser weapon systems at sea is becoming increasingly important. Lockheed Martin has developed the Helios laser system, which has been installed on the USS Preble destroyer. One of the strengths of Helios is its incredibly fast attack speed, which enables the US Navy to counter threats from hypersonic missiles or attack UAVs in an extremely short time, something traditional weapon systems cannot achieve. Military experts estimate that the laser system can destroy a hypersonic missile traveling at Mach 5 within 1 to 2 seconds after detection. The biggest advantage of installing a laser system on a warship is the ability to maintain offensive and defensive capabilities without relying on traditional fuel sources. This is particularly crucial in long-duration naval operations, where refueling traditional weapon systems can be challenging, especially in remote sea areas. According to our findings, laser weapon systems like Helios have been developed through several research and testing phases, with development costs reaching hundreds of millions of dollars. Reports from Lockheed Martin indicate that the development cost for a mid-range laser system can range from $100 million to $500 million. The Helios system is considered quite complex and could fall into the high-end segment of laser weapon systems. This is a clear example of how lasers can completely transform naval warfare, with the ability to destroy light targets such as sensors and drones. However, there is something you should note. This laser gun has a power output of 60 kilowatts. This means it is only effective against smaller targets. But when the USS Portland was equipped with a 150 kilowatt laser system, we witnessed a significant advancement. This laser is capable of neutralizing low-flying cruise missiles and even fighter jets. Recently, Lockheed Martin developed a laser system with an output of up to 300 kilowatts, called IFPC-HEL. This system combines multiple smaller laser beams into one powerful beam, capable of taking out more complex targets. What's unique about the IFPC-HEL system is how it combines several smaller laser beams into one powerful laser, vastly outperforming previous laser systems. Thanks to this technology, the HEL can target accurately, even in bad weather conditions, and destroy fast-moving, hard-to-defend targets. One of the standout features of the IFPC-HEL is its ability to handle complex threats in a very short time, thanks to real-time target identification and elimination. With the ability to burn through targets in seconds after detection, this system could change the landscape of modern air defense campaigns, helping reduce damage to personnel and assets. However, the most significant development today is the ultrashort pulse laser system. With a power output of up to 1,000 megawatts, this system is thousands of times more powerful than current lasers, taking only a fraction of a millisecond to destroy a target. With the ultrashort pulse laser, instead of melting the target like traditional lasers, we are witnessing a revolution. With just a few laser pulses, the target's outer shell is instantly vaporized. This is the future of warfare, where technology will continue to change how we defend and attack. So, what do you think about these incredible advancements? Could laser weapons replace traditional weapons in the future? Share your thoughts in the comments section of this video. When we think of laser weapons, images of powerful beams slicing through the night often come to mind. But in reality, laser technology has far surpassed what we see in action movies. In particular, the ultra-short pulse laser, USPL, has brought about a revolution in military technology, enabling the destruction of dozens of targets in a single second, no matter how fast they are moving. With impact times of just a few picoseconds, a USPL pulse can cause immediate damage to the physical structure of a target, shattering or damaging key components of a missile or aircraft before they can change course or initiate countermeasures. This is especially important in modern warfare scenarios, where hypersonic missiles and UAVs are becoming increasingly serious threats, demanding defense systems with extremely fast reaction time. A modern USPL, ultra-short pulse laser system can cost between $50 million and $100 million per unit, depending on its power and specific applications. While this is quite a high cost compared to traditional weapon systems, the fact that it doesn't require ammunition and can minimize damage from long-range attacks could help reduce overall costs in the long term. Moreover, the operational costs of USPL systems are much lower than traditional air defense missile or anti-aircraft artillery systems, as they only require electrical energy to activate the laser without the need to produce and transport expensive munitions. Do you agree that this is one of the military weapon systems worth investing in? Feel free to leave a comment below and share your thoughts. Countries such as the US, China, and Russia are heavily investing in the development of ultra-short pulse laser systems. This is especially important given the increasing global threats from UAVs and ballistic missiles. Imagine a cloud of hypersonic missiles heading toward you, and in the blink of an eye, they shatter into debris, falling like apples from a tree. Ultra-short pulse lasers have the ability to destroy targets at hundreds of miles without being significantly affected by environmental factors like fog, smoke, or plasma clouds. So what makes this type of laser so powerful? It's the superior technology and the ability to immediately destroy a target without interference from external factors. Can you imagine a laser beam so powerful that it can destroy a target from such a long distance? This is no longer just theory, it's a reality being deployed in cutting-edge military projects. But behind the mystery of these powerful lasers lies a big question. How do we power these laser weapons? In a virtual world, it might seem easy. Just take a machine and run it, and you'll have energy. However, in reality, to make this work, we have to overcome complex scientific barriers. The energy needs to be stored efficiently, and we can't just rely on conventional energy sources. Nuclear power was once considered the top option, but the problem is that this process requires bulky and vulnerable reactors on the battlefield. As a result, scientists have had to come up with a new solution: quark fusion. Did you know that in the universe, quarks combine to form atomic nuclei like neutrons and protons? This isn't just theoretical. It opens up the possibility of using the energy from quark fusion to power ultra-powerful laser weapons. Quark fusion, a concept that once seemed unfamiliar, has actually been developed by scientists in the US and Europe. This is a breakthrough in energy technology, and it could completely change how we think about modern warfare. Quark fusion generates 8 times more energy than traditional nuclear fusion, but without the dangerous chain reactions. This means that it's not only safer, but also much more efficient in providing power for advanced systems like ultra-short pulse lasers. With nearly unlimited energy output, advanced laser weapon systems could destroy targets from hundreds of miles away without needing ammunition. A laser system powered by quark fusion could destroy a hypersonic missile within seconds of detection, reacting incredibly fast, far superior to current air defense systems. For example, hypersonic missiles can travel at speeds of up to Mach 6, more than 7,400 kilometers per hour, but a laser system powered by quark fusion can track and destroy them in just 1 to 2 seconds. According to estimates from the Navy Power Channel, the development cost of quark fusion technology could exceed $10 billion in the early years of research, but once deployed, operating costs will be much lower, especially compared to traditional weapon systems. An impressive figure, wouldn't you say? However, this is not a simple solution. The quark fusion process is extremely complex and not yet widely applicable. If you'd like to learn more about quark fusion, feel free to leave a comment, and we can dive deeper into this technology in a separate video. However, despite the impressive advancements in laser technologies, there are still several notable drawbacks. One of the biggest issues is the potential for detection. Every military device emits a characteristic electromagnetic wave, and lasers are no exception. While these signals are invisible and imperceptible to the human eye, modern radar systems can detect and analyze these signals to identify the type of device in operation. Imagine radar as a keen ear capable of hearing the unique sound of each device. Ultra-short pulse lasers emit a distinctive electromagnetic wave which can be easily detected by enemies, reducing the element of surprise in combat. A study by the US Air Force Research Laboratory showed that radar systems can detect the electromagnetic waves of high-power laser systems within ranges of several hundred meters to a few miles. This means that if an ultra-short pulse laser system is deployed on the battlefield, the enemy can detect the trace of the laser beam as soon as it is activated. Modern radar systems, like the US Army's AN/MPQ-53, are capable of detecting and pinpointing electromagnetic signals with high accuracy, which increases the likelihood that the enemy can respond and counteract effectively. Imagine a combat scenario where an ultra-short pulse laser system is used to take down a hypersonic missile heading toward a military base. The hypersonic missile can travel at speeds up to Mach 5, around 3,800 miles per hour, and with a response time of just a few seconds, precision is critical. However, while the laser system might destroy the missile within 1 to 2 seconds, the enemy could have already detected the laser signal as soon as it was activated. What do you think about the fact that advanced weapons can be detected just through electromagnetic signals or sound waves? This is one of the challenges military experts must overcome in order to make ultra-short pulse lasers a truly unbeatable weapon. Another issue with ultra-short pulse lasers is their inability to attack indirectly. Unlike traditional weapons such as missiles or artillery, lasers can only attack targets they can directly see. This means that if the target is behind a wall, behind a mountain, or out of line of sight, the laser cannot affect it. This is a major limitation compared to other weapon systems that can attack along a curved trajectory, like ballistic missiles or artillery. What do you think about the direct attack capability of laser weapons? In modern warfare, do you see this as an advantage or a significant drawback? In a world where surprise is crucial, being unable to strike hidden targets could be a major issue. Although ultra-short pulse laser technology is advancing rapidly and holds great potential in the military domain, like all new technologies, it also faces significant challenges. Limitations in line-of-sight targeting, vulnerability to detection, and the need for enormous amounts of energy remain key issues that scientists and military experts must address. However, continuous progress in research and development will surely bring us closer to a future where lasers are not just science fiction weapons, but real tools of warfare. What do you think about the future of laser weapons? Will they change the way we fight in the future? Share your thoughts in the comments section below. If we look deeper into this technology, we see that ultra-short pulse lasers are not just offensive weapons, but also breakthrough defense systems capable of intercepting missiles and hypersonic vehicles with incredible precision. However, indirect targeting and detection still remain significant hurdles. Research into combining lasers with automated combat systems may be the key to overcoming these drawbacks in the future. The future of warfare may heavily depend on the integration of laser systems with automation technologies. If successful, these systems would not only enhance defensive capabilities, but could also significantly reduce response times and the need for human intervention, ushering in a new era of smart and efficient warfare. However, to achieve this, extensive research and testing are still required, from refining AI algorithms to developing supporting sensors and hardware, in order to make laser defense systems an essential component of global military strategies. Finally, before wrapping up today's video, don't forget to hit the subscribe button and activate the notification bell so you never miss any videos from Navy Power, where we bring you cutting-edge military technologies, modern strategies, and the latest events in the defense world. You'll always be the first to access the most up-to-date information and won't miss any of the fascinating topics we cover. Let's explore one of the most advanced fighter jets in the world, the F-22 Raptor. Known as a symbol of modern military technology, this aircraft perfectly combines stealth, advanced electronics, and high speed. The F-22 is not only a key component of global combat forces, but is also designed to quickly establish air superiority, neutralizing threats before they even see it. Lockheed Martin introduced the F-22 Raptor as the pinnacle of modern fighter jet engineering, describing it as an invisible and deadly predator capable of destroying Russia's Su-35 or China's J-10 from a distance of 93 miles. However, can the F-22 truly live up to this reputation? Join Navy Power to dive into the details of this aerial predator. Although it was introduced in 1997, the F-22 remains one of the most powerful and mysterious aircraft in the U.S. military. On September 7, 2024, the F-22 turned 27, marking a long journey in its illustrious career. Developed to replace the aging F-15 Eagle, the F-22 underwent a challenging 6-year research and production process. The total cost of the development program reached $66.7 billion, a massive investment to produce a cutting-edge fighter jet. So, what makes the F-22 a super fighter? Its stealth capability. With an effective radar cross-section of just 1.1 square feet, the F-22 appears minuscule on radar, smaller than a button in some cases. Measuring nearly 62 feet in length, with a wingspan of 43 feet, and weighing close to 44,000 pounds,
a very low observable target
the F-22
indeed.
appears almost invisible to enemy radar. This is achieved through a perfect blend of ultralight composite materials
In connection with the F-22 Raptor, its EP,
which reduce the aircraft's weight and minimize radar wave reflections. Additionally, the aerodynamic design of the F-22 is optimized to reduce radar reflections, with sharp angles and smooth surfaces, redirecting radar waves away from detection systems. The F-22 isn't just stealthy on radar, it also minimizes infrared detection through exhaust management and dispersion of infrared signals. Furthermore, the F-22 is equipped with F-119 PW100 turbofan engines produced by Pratt & Whitney, enabling a top speed of 1,500 miles per hour. Although this speed doesn't surpass Russia's Su-35, 1,725 miles per hour, the F-22 can maintain high speeds for longer durations, allowing it to maneuver quickly and efficiently in the air. This system not only delivers exceptional performance, but also reduces infrared signatures with multi-angle exhaust ducts, making the aircraft harder to detect with infrared sensors. The combination of stealth materials, aerodynamic design, and an engine system that minimizes infrared signals creates comprehensive stealth capabilities, enabling the F-22 to dominate aerial combat and execute strikes without being detected. Additionally, the F-22 features the advanced AN/APG-77 radar system, capable of detecting targets at a range of up to 100 miles, while adversaries can only detect the F-22 from a maximum distance of 31 miles. This means the F-22 can eliminate targets without them ever knowing, a realization of the first look, first kill concept, where the F-22 identifies and attacks before its opponent. So, is the F-22 Raptor truly the most formidable predator in the sky? With its advanced technology, speed and stealth capabilities, the F-22 is not only powerful, but also a symbol of modern military strength. The F-22 Raptor is more than just a fighter jet. It's a war machine designed to manipulate space and time, always staying one step ahead of its adversaries, a testament to the relentless advancement of military technology. But can it maintain its dominance against next-generation fighter jets in the future? Share your thoughts in the comments section below this video. How do you think the F-22 would fare in a face-off against newly emerging fighter jets? We look forward to hearing from you. The F-22 Raptor is not just a peak performance fighter jet. It is a symbol of modern military technology and an unprecedented achievement in the history of military aviation. Dubbed the Invisible Sky Killer, the F-22 combines stealth, speed, and superior combat capabilities. With a top speed of 1,118 miles per hour, the F-22 can fly at 1.5 times the speed of sound without requiring afterburners, an exceptional feat in aviation. This capability makes the F-22 not only a fast aircraft, but also fuel-efficient and quieter, offering strategic advantages during swift attacks or retreats. But the F-22's strength lies in more than just speed. It maintains precise roll control during advanced maneuvers like the Herps maneuver and Cobra Pugachev. In the Herps maneuver, the F-22 can abruptly change direction and speed, decelerating and hovering mid-air to create tactical openings for attack or escape. This technique requires advanced electronic control systems to ensure stability and allow pilots to manage the aircraft effectively during rapid shifts in direction and speed. Similarly, during the Cobra Pugachev, the F-22 executes a sharp upward pitch, nearly stalling mid-air, before accelerating forcefully. This maneuver helps the aircraft unpredictably reposition, leaving opponents unable to follow or anticipate its next move. Both maneuvers not only give the F-22 an edge in dogfights, but also enhance its tactical stealth, making it harder for adversaries to approach or target it accurately. These maneuvers represent a revolution in aerial agility, enabling the F-22 to maintain absolute control and a strategic advantage in three-dimensional airspace. It's not just fast, it's astonishingly agile, creating moments where opponents can only watch helplessly. So what powers this formidable aircraft? The F-22 is armed with 6 AIM-120C AIM-RAM air-to-air missiles with a range of up to 75 miles and 2 AIM-9M Sidewinders with a range of 22 miles. Beyond air superiority, the F-22 can also carry JDAM GBU-39 and SDB-53B bombs, along with a 20mm M61A2 Vulcan cannon capable of firing 480 rounds per minute. Notably, all these weapons are stored in internal bays, preserving the F-22's stealth capabilities by minimizing radar cross-section, rendering it nearly undetectable in flight. In addition to its advanced arsenal, the F-22 is designed for extreme survivability. It can withstand attacks from 30mm cannons used by Russian fighter jets and endure explosions and incendiary shrapnel. This resilience makes the F-22 an almost invincible aircraft in aerial combat, ensuring it retains air superiority. However, the F-22 is not without its flaws. Initially planned for 750 units, production numbers dwindled drastically over the years. By 2011, when production ceased, only 195 units had been completed, a modest figure compared to its original goals. Why was production halted? Despite its near-perfect design, one major drawback is its exceptionally high operating costs. Each flight hour costs approximately $68,000, far higher than other aircraft like the F-15C, $42,000, or the F-16C, $22,500. This raises significant questions about the sustainability of maintaining the F-22 in the long term, especially under strained defense budgets. Additionally, the F-22 is limited by its range of only 472 miles and its relatively modest ground attack capabilities, restricted to precision-guided bombs. Another weakness of the F-22 lies in its limited ground attack capability. While it excels in air combat, its effectiveness against mobile or complex ground targets is quite restricted. The aircraft can only carry precision-guided bombs like JDAM or SDB, lacking heavier weaponry or specialized air-to-ground missiles in its arsenal. Additionally, the F-22 is not equipped with dedicated sensors or targeting systems for ground attack missions, making it challenging to detect and engage sophisticated ground targets. As an air superiority fighter, the F-22 cannot match the ground attack effectiveness of specialized aircraft like the A-10 or F-15E. This limitation makes the F-22 less ideal for missions targeting mobile or intricate ground objectives. Nevertheless, the F-22 retains its strategic value. In 2021, the U.S. Department of Defense signed a $10.9 billion contract with Lockheed Martin to upgrade the F-22, extending its service life into the mid-21st century and potentially until the 2060s, when sixth-generation fighters will replace it. This highlights that despite its flaws, the F-22 remains an integral part of the U.S. Air Force. The F-22's unique features have made it a standout fighter jet. Although only 195 units were produced, this number underscores its significant role in global military strategy. The U.S. government has also enacted a law prohibiting the export of the F-22, even though countries like Japan, Australia, and Israel have shown strong interest in acquiring it. In summary, the F-22 Raptor is a symbol of American military strength and technological prowess, despite challenges with cost and ground attack limitations. With ongoing upgrades and enhancements, the F-22 will continue to play a vital role in the Air Force until it is replaced by next-generation fighters. Upgrades include an improved radar station, a new optical navigation system integrated into helmet displays, and advanced communication devices, enhancing its coordination capabilities in air combat. Notably, a new stealth coating inspired by the F-35 and advanced air-to-air missiles are among the critical enhancements planned for the F-22. But before moving forward, have you ever wondered why the absence of an infrared search and track (RST) sensor is such a critical issue? Share your thoughts below and join Navy Power in exploring more. For the F-22, its radar is one of the key components contributing to its superior capabilities. The F-22's radar can detect a Su-35 from a range of 140 to 160 kilometers while maintaining stealth against Russian pilots. However, the situation is not that straightforward. While the F-22's radar is powerful, it operates mainly in active mode, emitting signals. A notable weakness of the F-22 is its lack of infrared sensors. While its radar excels at detecting long-range targets, infrared sensors operate passively, enabling target detection without emitting signals and thereby preserving stealth. This decision stems largely from budget constraints, as the F-22's development costs were already high, prompting officials to cut this feature to reduce expenses. So, what upgrades will make the Predator F-22's nickname stronger? Air-to-ground missiles like the AGM-158 JASSM, already used by the F-35, will be integrated into the F-22's arsenal. Additionally, outdated air-to-air missiles like the AIM-9M and AIM-120C will be replaced by more advanced versions such as the AIM-9X and AIM-120D. This upgrade will undoubtedly enhance the F-22's attack and defense capabilities. Moreover, F-22 pilots will be equipped with HUD, head-up display helmets similar to those of the F-35, featuring JHMCS, Joint Helmet Mounted Cueing System technology. This allows pilots to control targets simply by turning their heads, without needing to change the aircraft's direction. What do you think about these upgrades? Are they sufficient to maintain the F-22's dominance, or will we soon witness the emergence of a more powerful generation of fighter jets? Stay tuned to Navy Power for more analysis. Replacing the F-22's older stealth coating with the advanced version used by the F-35 is a logical and understandable decision. The reasoning lies in the fact that, while the F-35 came nearly 2 decades after the F-22, its stealth coating technology has significantly advanced beyond its predecessor. When the F-22 was first designed, its stealth coating was groundbreaking, but over time, the F-35 has adopted superior materials that reduce radar cross-section, RCS, and enhance its ability to evade enemy radar. More importantly, these improvements not only preserve the F-22's status, but also lay the foundation for 6th-generation fighters, such as the NGD, Next Generation Air Dominance, and FX projects to handle air defense missions in the future. These new fighters will inherit and expand upon the F-22's advancements, continuing to protect American and Allied airspace in the decades to come.